Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Muzammil bin Muhammad Rizal, and right now I show you how to do the stimulate the Laplace in MATLAB. Okay, the lab activity on the first Roman, on the first question, first Roman, convert the following frequency domain expression into the time domain using MATLAB command. Okay, right now it asks from frequency domain expression into time domain using MATLAB. That means we're gonna use the I plus. Okay, like the first question, the first Roman. First, we gotta declare the S, and then we just copy the equation. The same equation is H equal to S plus 2 over S squared minus 3S, 3 times S. And then we hit enter, and then this is the new equation. And then we wrote the I Laplace, inverse Laplace for the H. And then this is the final answer. 5 exponent by the power of 3t over 3 minus 2 over 3. Okay, for the second questions, um, we do the same as the first question. We declare the S, and then we copy the equation like G equal to S over S plus 4 multiplied by S times 8, S plus 8, and then we hit enter. Then this is the new equation. This is the equation. Then we wrote I Laplace inverse Laplace G, and then this is the final answer. 2 times exponent by the power of negative 8t minus exponent by the power of negative 4 times t. Yeah, for the second questions, the following time domain expression into frequency domain using MATLAB command. Okay, the instructions show we need to convert the time domain expression into frequency domain. It means we just use the Laplace. Okay, first we declare the t, the time, the t, and then we copy the equations. Y equal to 1 minus 2 exponent by the power of negative 2 times t plus exponent by the power of negative 8t. Then we hit enter, and then there is the equation exponent by the power of negative 8 times t minus 2 exponent by the power of negative 2 times t plus 1. And then we straight to Laplace the y, Laplace the equations, and then we get the final answer 1 over s times s plus 8 minus 2 over s plus 2 and plus 1 over s. And then we do it again for the second Roman, sims t, and then we declare the t, and we copy the equations. 5 over 9 minus 5 exponent by the power of 2t times 2 negative 2 times t plus 10 over 3 exponent times exponent by the power of negative 3 times t plus 40 over 9 times exponent by the power of negative 3 times t. Then we hit enter, and this is the new equations, and then we Laplace it on the f function, f equations, and we get the answer of 70 over 9 times s plus 3 minus 5 over s plus 2 plus 5 over 9 by 9 multiplied by s, 9s. Okay. Okay, for the lab activity 2. Okay, first of all, create new simulating model to create design system as figure 1. Okay, and then step in, put step time to 0. Okay, put steps set time to 0. And then change the gain variable k to 1. Okay, first we change variable k to 1. Then hit enter and start to play. Okay, when we play, then this is the first graph. Okay, this is the first graph for the gain variable k. We change to 1. This is the first graph, and then we change it to 2. Then okay, then this is, we just plot, and then this is the second second graph, time series plot. Okay, next is it for next. Okay, for next we change it to 10. We change it to 10. Okay, we hit enter. Okay, then we run. Then we run and start set command for plot, and then this is the third graph. This is the third graph. Okay, right. And then okay, for the next step is, okay, keep the gain equal to 10. We keep the gain equal to 10 and replace the step input with the RAM input, and we run the simulation. Okay, I already convert the step input into RAM input, and yeah, and comment the plot, step to response, and record the result, and the result is this. This is the result for the RAM output. Okay, and then okay, zoom in the graph at t equal to 10 seconds. Record the final input, represent your system in root locus, and record the result. This is the root locker graphs. Okay, alright. For the lab activity 3, you use the MATLAB command find ds cs over rs the close loop. Okay, the function we will use is the gs and hs. Okay, then we copy the transfer function equations as less than tf 1 to 1 is equal to s plus 2 over s multiplied by s minus 1 and times s plus 3. And we get those equations. This is the final answer because the upwards will times by tens. The numerator will times by tens, and the denominator will be expanded. Okay, then the h, we use the same command, transfer function s plus 1 over s plus 3. Okay, then we use the t because we find the t, we write th. Then this is the final answer because the product of the t is gs is better from hs, and this means gs over 1 plus gs times hs. This is the final answer. Okay, for the step, final step, yeah, for the step, we just
just type the step to T and enter. Then this is the first step response. Okay, and then for the second, use our first for the key. Then we run. Okay, this is the second purpose. The second proper purpose. Then the third is uh, for block. Then both key. No, you cannot. This is the diagram. Okay, that's all for the lab sheet.